Hey, geometry students. You have two more worksheets. This one is with probability, okay? And so we're going to be talking about independent and dependent events. So let's go over these and then I can kind of explain what that means. So, number one, you flip a coin and then roll a fair six-sided die. The coin lids heads up and the die shows a 1. So between a coin and a six-sided die, do those have anything to do with each other? Can you get, I guess, the same outcome with either one of those? Or, are these two separate events? These are two separate events. The coin doesn't depend on the die when you roll it. So this one would be independent. Okay, there are only two outcomes with the coin and there are 6 outcomes with the six-sided die, but they don't depend on each other. Okay? Alright, so for the second one, a bag contains 8 red marbles and 4 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. So, first marble they're saying is red and the second is blue. So let's say you pick that red marble. So think about that. A bag contains 8 red and 4 blue. So you have 8 plus 4 or 12 marbles in the bag. Okay. If you were to pick a red marble, the probability of picking that would be 8 out of 12. And then it says you don't return the marble to the bag. Once you pick that red marble, you're not returning it. So then you only have 11 marbles in the bag at that point, right? Once you've picked that one marble, you have 11. So for the second pick, it's out of 11 marbles, all right? And they're saying what's probably the picking a blue. Well, you'd still have the 4 blue marbles in there. So that would be 4 out of 11. But the point is that these depend on each other. This probability depends on whether or not I put that marble back in the bag or not. In this case, I did not put the marble back in the bag. So again, that second probability depends on the first one. So that is called a dependent event. Next one. A box of chocolates contains 5 milk chocolates, 5 dark, 5 white. You randomly select and eat 3 chocolates. So the first piece is milk chocolate, the second is dark chocolate, and the third is white chocolate. So you got to think, will you be putting chocolates back? Okay? If I eat a milk chocolate piece, I'm not going to put it back like it's in my stomach, right? So then the next probability is going to depend on the fact that I ate a chocolate, basically. And then the next probability after that is going to depend on those 2 events before it. So these are dependent. All right? A cooler contains 10 bottles of sports drink, 4 lemon lime, 3 orange, and 3 fruit punch. 3 times you randomly grab a bottle and you return the bottle to the cooler. So the key word there is return. You put them back. So if I pick a lemon lime drink the first time, it says that'll be a certain probability. And let's see, how many did we have? 10 altogether. So there'll be 10 water bottles or sports drink bottles in this cooler. And then if I return that one to the cooler again, then there are still 10. Okay, so I have an equally likely chance again, 10 bottles here again, of picking another one. So these are independent because you returned the bottle each time. Okay? So now we actually have to find the probability. So this is how we do this. For events that happen one after the other, you end up like multiplying the probabilities that you get, and I'll show you what I mean. So you flip a coin and then roll a fair six-sided die, just like that number one on the top. The coin lands heads up, and the die shows an even number. So let's find the probability of the coin landing heads up. So how many outcomes are there on a coin? There are 2, heads and tails. So for heads, it would be 1 out of 2, because you can get a heads. That's the outcome we want. There's 1 possibility of getting that out of 2. Now for the even number, you got to think, 6-sided die. So that's 1, 2, 3, 4, 5, and 6. So that's the bottom number. There's 6 possibilities. And how many of these are even? 1, 2, 3. So there's 3 even possibilities. So now we're going to multiply those 2 together, because this is like event 1 times event 2, the probability of event 2. And so we end up getting 3 out of 12. Okay, 3 times 1 is 3, and 2 times 6 is 12. And then when we reduce that by 3, divide this by 3, divide this by 3, you get 1 over 4. Okay, so that's the probability of those happening one right after the other. All right, next one. You roll a fair 6-sided die twice. The first roll shows a 5, and the second roll shows a 6. What's the probability of getting a 5 the first time? There's only 1 5 on the dice, so 1 out of 6 possibilities on a die, right? And again, the second one, these are independent events. They don't, there's 2 separate things. They don't depend on each other, so I'm just going to multiply the 2 probabilities together. And they'll both have 6 possibilities on the bottom. So for that second one, the probability of getting a 6, there's only 1 6 on the die, so that's 1 out of 6 again. So if I multiply across now, 1 times 1 is 1, and 6 times 6 is 36. So that's the probability that you'll get, that those 2 events will happen, one after the other. All right. All right, so this one right here, there are 8 shirts in your closet, 4 blue and 4 green. You randomly select one to wear on Monday and then a different one on Tuesday. Okay, so now I'm going to assume that these shirts are dirty, that you're not going to return them to the closet. So these are actually dependent events if you don't return them to the closet. So there are 8 shirts in your closet, again, 4 blue, 4 green. And so this is saying you randomly select one to wear on Monday and one on Tuesday that's different. And again, that one on Monday ends up getting dirty, so you probably wouldn't put it back in the closet. So it says you wear blue both days. So the first day, how many blue are there in the closet? It says 4 blue. So 4 out of how many shirts? 8 shirts. But then that next day, this is a dependent event. The next day, when you pick a shirt, that previous blue shirt is dirty. So now we only have 7 shirts in the closet. And if I picked one of those 4 blue shirts, then that means that there are only 3 blue now left in the closet. So now when I multiply across 4 times 3, I get 12. And 8 times 7 is 56. And again, I could have reduced this, honestly, ahead of time. That's 1/2 times 3 over 7. Okay. But if you wanted to reduce this by 4 afterwards, you could. But if I were to reduce this ahead of time, then that would be 1 times 3. And 2 times 7 is 14. So that's the final answer to that. Last one. A basket contains 5 apples and 7 peaches. You randomly select one piece of fruit and eat it. Again, you're eating it. So that means it's not going to go back into the basket. So these are dependent events. You randomly select another piece of fruit. So it's saying the first piece of fruit is an apple, the second is a peach. So again, we have 5 apples, 7 peaches. So the probability, so first of all, let's find the total. 5 plus 7 is 12. So you have 12 pieces of fruit in the basket. So that's going to be our bottom number for the first pick. So we have 12 pieces in the basket. And the first one it's saying is an apple. So how many apples? There are 5. So you're going to say to get an apple, that's 5 out of 12. Okay? But then the second time, you picked something and ate it. So now you have 1 less piece of fruit in there. So now we have 11 pieces of fruit. And then remember, the first one we picked was an apple. So then if we want a peach the second time, we still have all 7 peaches in that basket. So that number to get a peach is 7 out of 11 at this point. And now we can multiply and find our answer. 5 times 7 is 35. And 12 times 11 is 132. Okay? And so that's our final one for those. And again, it's a dependent event. Okay?